So section 9.5, how is a right triangle used to find sine and cosine of an acute angle is our essential question. Right. So we're looking at trig functions. So we looked at tangent in 9.4, and here we're going to be looking at sine and cosine, which are the other two trig functions that we'll be going over. Right. So sine, your sine ratio, right? We abbreviate that SIN, right? So then that, if we're going to compare this to A, so let's say the sine of A, right? And that's the opposite leg over the hypotenuse. Okay? Right? So your opposite leg and hypotenuse. Cosine, so we're going to do the cosine, we abbreviate that COS, right? Of A, that's the adjacent over the hypotenuse. Right. Again, realize that if we switch the angle to C, your opposite and adjacent would switch. All right, your hypotenuse would still be opposite to 90. So a couple things with what we need to do with our trig functions. One is remember and know which one I'm using when. All right, so there's a bunch of ways you can remember that. The most common, right, is called SOHCAHTOA. Right, and that's an abbreviation. The capital letters S, C, and T are our trig functions. The lowercase letters are sides in the order. So sine is opposite over hypotenuse. So opposite is first, then hypotenuse. Cosine is cosine. Right? So I have adjacent over the hypotenuse. And tangent is opposite over adjacent. Right? So SOHCAHTOA, right, is to remind me, all right, I'm looking at, I have opposite and hypotenuse, what am I using? Right? The bad joke I always tell to help you remember this is if my geometry book, which you guys don't have this year, is heavy, if I drop my geometry book on my foot, I need a SOHCAHTOA. Right? If you don't get that, that's probably good. So one of the things I need to look at here, this says sine of u. All right? So what I need to think about is where am I at? What am I doing with sine? Right? So this says it actually says find sine, cosine, and tangent. I'm not going to show the tangent on here, but I will mention it. Right? Write each answer as a fraction and as a decimal. Right? So I'm not solving. Right? I'm not actually solving on any of the front. I'm just doing the fractions on the front. Right? So u is here. My opposite is 16. And my hypotenuse is 34. And sine is opposite over hypotenuse. So I have 16 over 34. Since we're keeping that as a fraction, I want to reduce that. Which reduces to 8 over 17. Then I'm just dividing the fraction. I'm not doing anything on my calculator with the sign button. All right, we'll get to that in a minute. All right, so my decimal is 0.4706. Okay. Cosine of u, so I'm working from the same angle. My hypotenuse never changes. Okay, and cosine, I'm doing the adjacent on top. So that's the 30. So I have 30 over 34. That's 15 over 17 when I reduce it. Right, and the decimal equivalent of that is 0.8824. Which you can't see. There we go. Right. Then example 2. Right. It asked me to fill in the blank, so these are going to be fractions. Leave as your simplified fraction. Right. So sine of C, I have C. Right. It's opposite over hypotenuse. So 20 over 29. That does not reduce. Right. Then cosine of C, all right, I want to go down. Cosine of C, adjacent over hypotenuse, so 21 over 29. Okay. Then these two switch to B, right? So my hypotenuse is still the 29. My opposite and adjacent will switch, right? So B, the opposite is 21. The hypotenuse is 29. B, the adjacent is 20, the hypotenuse is 29. Okay. And if you notice, these fractions basically flipped, right? That's because when I switch my angles, my opposite and adjacent change, but my hypotenuse doesn't. So the bottom's going to stay the same, but your top switch if you switch what angle you're looking at, right? With the tangent, which was mentioned, right, that's opposite over adjacent. So what would happen in that, right, B would be 21 over 20, C would be 20 over 21. So that fraction flips when we're looking at tangent. So then as we flip this over, all right, we're going to look at setting these up and solving. All right, so here we're actually going to use our sine, cosine, tangent to solve these. All right, so it says find the length of the leg, use sine, cosine, and tangent to find the value. All right, so first thing I want to do is we'll go through and do our setups on these, and then we'll talk about solving. Right, so here I have my 48 degrees, right? I have 10, which is adjacent, and then I have B and A. So I want to solve each variable separately, right? So I'm going to have two equations. Since I'm using the adjacent, when I do we'll do the hypotenuse first, because that's A. When I do the hypotenuse and adjacent, that is cosine, right? That's why I need to know these over here, right? Because I need to be able to say, all right, I'm looking for the hypotenuse, I have the adjacent, what trig function am I using? I'm using the cosine of 48, right? Adjacent over hypotenuse, 10 over A. Then tangent of 48 would be my other one, because I have my opposite and my adjacent. So I have B over 10. I'll talk about plugging these in the calculator in a minute. I'm going to run through and set them up first, and then we'll run through on what we would do on the calculator. Right. So here I have 50. The angle I'm given is 8. Right. The side I'm given is 8. That's my opposite side. So that means I'm going to use sine, opposite over hypotenuse, and tangent, opposite over adjacent. All right. So I do the sine of 50 equals opposite over hypotenuse, and the tangent of 50 equals opposite over adjacent. All right, C I'm only looking for one side, which is my x. All right, so I have the 39. I have the hypotenuse, which means I'm using sine or cosine, and then I have the adjacent, which means I'm using the cosine. So I'm doing the cosine of 39. Adjacent over hypotenuse, right? And then D, right, we're looking for R and S. Again, I have the hypotenuse. So R, right? R is in the same position as the X. My number here changed, but I'm doing the same exact setup. The cosine of 49 equals R over 26. Then S is the opposite. I still have the hypotenuse. So I'm now doing the sine of 49 equals S over 26. Okay. Now, when I'm solving these, right, we have the paper, and my paper from yesterday, right? We went over in 9.4 how to plug tangent into our calculators, right? I'm doing the exact same thing. What's changing is the button I'm hitting. So on your calculator, there's next to the tangent button, there's a sine and cosine button. So you're using that button instead. Everything else stays the same. All right, so you're plugging in those numbers. So cosine of 48 equals A over 10, right? The A is on the bottom. So I'm doing division. I'm doing 10 divided by the cosine of 48, right? So when I do that, I'm going to get that A is 14.94. Right, again, remember to make sure you're in degrees, make sure you're typing it in the correct way for your calculator. All right, and I talked about that in the 9.4 video, so make sure you look at that if you don't remember how to do that. Okay, that's 14.94. Right, B, this is on the top. So on the top, I'm multiplying. I'm doing 10 times the tangent of 48. Right, when I plug that in, I'll get 11.11. Right? And again, I'm saying 10 times the tangent of 48. Some of your calculators, you're not plugging it in that way. So make sure you know what you're doing on your calculator. Both of these, I'm on the bottom. All right? So the only thing that's changing when I solve these two is whether I hit sine or tangent, because I have 50 for both and I have 8 for both. All right? So I'm doing 8 times the sine of 50 for n, which gets me 10.44. And I'm doing 8 times the tangent of 50 for m, which gets me 6.71. Right? Now C, we switch, now we're on top again, right? So on the top, hold on, I said that wrong. I said these two wrong. I did the math right, I said it wrong. I'm dividing. So I'm doing 8 divided by the sine of 50, doing 8 divided by the tangent of 50. All right, to get these two. All right. C is where I'm multiplying because x is on top, so I'm doing 26 times the cosine of 39. That gets me 20.21. All right. D, again, now here they're both on top, so both of these are multiplication. Right, I'm doing 26 times the cosine of 49, 26 times the sine of 49. Right, so R, we get 17.73. S, nope, I flipped these. R, we get 19.02. S, we get 17.73. Right. You can also do these with word problems. All right. Again, look for what you're looking at. The angle of depression is 11 from the bottom of the boat to the deep sea down to a depth of 120 feet. Find the distance that the driver must swim up to the boat to the nearest foot. All right. So these are always going to be right triangles. All right. There's a couple ways you can look at these. Right? The angle of depression, that's when you're looking down. All right? So if I'm standing here, I'm looking down 11 degrees. Right? So this is the direction I'm going. Right? I want to know how far up the diver has to swim. Right? So so they dove down 120 feet. The distance they must swim up, so they're not swimming straight up because we know that that's 120. They're swimming up this distance, right? That's my x. So the 11 degrees is here, right? So this is the hard thing about the angle of depression stuff, and I'm editing my triangle a little bit. This is 90 degrees. This is 90 degrees. These two triangles are congruent, all right? So this is 120. My hypotenuse is still x. This angle here is 11. All right, so watch the angle up here. I can solve this. It's 90 minus 11, right, which would give me 79. So I could use that. But if you're using the 11, realize that you're working from the angle down here, or you're looking at this triangle. All right, so I have the sine of 11. X is my hypotenuse. We said the 11 is here, so 120 is opposite. So that's why we're doing sine and opposite over hypotenuse. So here, x is on the bottom. I'm dividing by the sine of 11 at 628.90. And it says the nearest foot. So my final answer would be 629 feet. Right. On example 5, they show me the picture. The angle of depression from the T-box is 10 degrees. So they show me that here. On a par 3. The par 3 doesn't matter. That's if you're not familiar with golf. That's telling me how hard the golf course is. So this par 3 has nothing to, that 3 has nothing to do with our math problem. Right? 185 yards from the hole. They show that distance. Right? How much higher is the tee box than the green? So I'm looking for the height here. That'd be the same height here. Right? Depending on where you're looking. Right? So I have this side or this side, depending on which triangle you're looking at, right? And I have this side, right? So that's my opposite and my adjacent. I don't have this thing here is going here, which is my hypotenuse. That means I'm using the tangent, right? So I'm doing tangent at 10 degrees, and I'm going to do, if I'm the 10, opposite over adjacent. So what I'm looking for over the 185. Meaning here I'm multiplying 185 times the tangent of 10. So x is, let me check my math on that. Can't tell if I have a decimal point written down or not. 185 times the tangent of 10. Ew. Why do I get something much different? Wait. Dude, did I write something wrong here? Opposite over adjacent. Alright, I think my initial setup was wrong. Yeah, alright, so this is completely wrong. Glad no one caught that in all these years. So the 185 times the tangent of 10. Alright. 32.6 to the nearest yard is 33 yards. Alright. Ooh, you can't even see what I'm doing there. Alright. Alright, so that is our trig functions. Right? And make sure you know sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Right? And then knowing how to plug that in your calculator, which we went over in 9.4. If you need to look back at that. Tomorrow with 9.6, we will look at using these and finding the angle, right, which we looked at calculator-wise on the tangent one. We'll actually do some problems with that tomorrow.